Hello. In today's lecture, I will be discussing the reconstructing of geologic history, stratigraphic correlation. So, what is stratigraphic correlation? Whenever we start talking about stratigraphic correlation, this is basically taking and reconstructing the geologic history of like 3 different outcrops, as you see here, and then making them into one complete story. What you have to remember is not every outcrop is going to have the entire history recorded, because weathering and erosion may have removed a rock layer. So it's kind of like equivalent to ripping a page out of a book. And so what we really have here is we have 3 books that are really telling the same exact story, but all of them are missing these different pages. And so what we have to do is we have to correlate them to actually reconstruct them and make one complete book. And we can do this using several different methods. We can use lithostratigraphy, which is basically using the same type of rocks, or we can use biostratigraphy, which is using fossils that are found within the rocks themselves. So those are the 2 primary methods that you're going to look at. But today we're going to go ahead and use lithostratigraphy as the primary way of actually determining the geologic history of an area. So again, it's really just like taking 3 books that are telling the same story and combining them into one book, and it's going to give us a more complete history. Okay, and then of course what they do is they reconstruct these things, as you see over here on the right, called a stratigraphic or strat column. Alright, so how do you go about doing this? So let's say that we have these different rock layers here. You can see we're trying to correlate each one of these, and from that correlation we can actually reconstruct the entire history and put them into a proper relative sequence. Alright, so unfortunately you can see one I've already got marked here. So that right there is a match, but we'll go through each one of them so that you can see how it actually works. Alright, so I'm going to start on the strat column on the left, the fossiliferous limestone, and I'm going to match it up. And then you can see I'm going to go ahead and match up the red sandstone, the siltstone, the shale, and then of course that sandstone actually matches. Now you notice that you're left over here with the black shale, the black limestone, and the shale containing trilobite fossils. Well, you don't see them in this strat column, but you do see them over here. Okay, and so the question becomes is, how do I know that this sandstone doesn't match up with the sandstone here? Well, that's because this sandstone is not containing dinosaur fossils. So that tells me a completely different thing here. Okay, so let's continue on with our developing here, or constructing our strat column, our complete strat column. So as you can see, I've matched up the sandstone already. But then I match up those black shales. Now, the one thing that I don't like about having to do this like this is that you see that they cross. Well, their only crossing is because this is actually located lower. Okay, so that sandstone is clear down here on the bottom. And so whenever you do this, notice how these over here do not cross. That's a rule that you have to have. Okay, and so whenever you start looking at that, you have to say, okay, I know I can't have them cross here, but in this case, because this C strat column is completely uplifted over there, it looks a little different. And then I match the black limestone, and then I match the shale. Okay, and so what you end up doing is now you've kind of correlated all of them. So now what we want to do is we want to put them into relative order of occurrence. And well, so what you have to do here now is you have to switch back over to using your principles of relative dating. Specifically in this case, it's going to be superposition. Everything on top is younger than everything on bottom. Okay, so you have to remember that this sandstone is really matching up way down here. So just, you kind of have to imagine that whole strat column shifting downwards so that we can do that. All right, so here's what we're looking at. What you're going to see is you're going to notice that the glacial deposits in the sandstone with a dinosaur fossil, they don't really match up to anything, but they're on top of this layer. So that makes them, of course, younger. Okay, so the glacial deposit is younger than the sandstone with dinosaur fossils. Then we have the fossiliferous limestone. Then we have unconformity XX, which, we'll look at that. So there's missing rock layer there. And then you have the red sandstone, the siltstone, the shale, the sandstone, and then you go with basically this. Okay, you go with glacial deposits being the youngest. Then you have the sandstone with the dinosaur fossils. Then we have the fossiliferous limestone. We did leave unconformity out right here, but it does fall in between. So we do know that there is a missing rock layer right here. So we'd have to go to another location to figure that out, but that's not what we're doing right now. Okay, then you have the red sandstone, the siltstone, the shale, the other sandstone, which all three of those correlate. And then you have the black shale, the black limestone, the shale with trilobite fossils, and then finally at the bottom, the gray limestone. So this, through the principles of correlation, what we've actually done is we have now reconstructed a complete stratigraphic column with all of these layers of rock, and it allows us to reconstruct more of a history of sea level transgressions and regressions and everything that took place in this landscape. So hopefully this video explains how you go about the principle of correlation, and then you use your principles of relative dating to actually put them into a geologic sequence of occurrence or relative date them. Okay, if you have any questions, please do not hesitate to email me.